All right. So welcome everyone to our next session on Architecting for Information Security Manual Compliance on AWS. Now this is a level 300 session and we're going to focus around stepping confidently into the future of secure cloud adoption and discover how to architect for ISM compliance on AWS and empowering your organization to meet Australia's highest security standards with practical guidance. It's now my pleasure to welcome on stage Farhan Farooq and Chamandeep Singh.
Thank you, Mehak. Welcome, and it's great to see you all here today. I am Cham Singh, a Senior Security Partner Solutions Architect here at AWS. A quick setting up the expectations. We'll begin by understanding what AST's Information Security Manual is and why it's fundamental to government agencies building secure cloud environments. We'll walk you through with some of the reference architecture as part of this talk we have built. It's so important to understand that ISM manual is quite vast and it's beyond the scope of this 30-minute session. But we have taken a balanced approach to come up with technical reference architecture as well as the mapping with cybersecurity guidelines. By saying that, it's also important to understand the security shared responsibility model, which is fundamental for any discussion. And you may have seen this slide already in few of the discussions in AWS Sydney Summit. So it clearly delineates the responsibility between AWS and customers. So AWS responsibility is of the cloud, and customer responsibility is security in the cloud. AST ISM has 5 key cybersecurity principles that offer strategic guidance in terms of how you can or your organization address cybersecurity risk effectively. And these principles are govern, identify, protect, detect, and respond. Think of this as a ladder where you can be at a different maturity level. If you have just started, you are initial stage. Or if you are introducing automation, you could be optimizing stage as well. Now, this is great in terms of strategic direction. How about the practical implementation? The cybersecurity guidelines talks about or suggest 22 guidelines and 900 control the technical implementation of these, which also talks about people and processes. Now, Australian government uses 6 classification levels from unofficial to top secret to assess the sensitivity of the data. AWS Cloud Services has been assessed at the protected level, which you can see marked in the screen as well. Now, we have aligned the ISM with AWS Cloud, some of the controls. I'm going to hand over to my colleague, Farhan, to take you with that journey.
Thanks, Cham. So yeah, what we'll be doing now, addressing EU cybersecurity principle, and we'll see that how it corresponds to cybersecurity guidelines and how AWS services or features can be associated with those. So what we have done, we're going to start with the first cybersecurity principle, which is govern. Now, govern talks mostly about governance and processes, but it has some technical aspects as well, right? What we have done is this mapping. So this mapping you probably don't find, will not find out there, that how to relate with cybersecurity principles with cybersecurity guidelines. So what we have done is we try to put, okay, these are the controls that can be associated with particular cybersecurity principle. So in this case, govern has 3 cybersecurity guidelines, right? And what we have done is that we try to pick up AWS services and features that can, if applied, can help you in achieving your control objectives for that particular control, right? Within ISM. But the main thing is that how, the question remains that how would we know that this association works? This is what we're going to be talking about, right? In next slides. What we're going to be doing is that we're going to be selecting few controls. Of course, there are 900 plus controls. We cannot, if we talk about them the whole day, it will take 2 or 3 days to complete them, right? So we're going to start with first control. So cybersecurity guidelines has section if you look here, subsection, and then the corresponding control. Now, if you look at this controller, for example, which is ISM 0414, it talks about creating unique identities, right? Now, how we're going to achieve this in AWS is using AWS IAM Identity Center. Now, IAM Identity Center lets you create unique identities. You can apply specific IAM policies for fine-grain or coarse-grain access control, but if you look deeper into that control, this control specifically talk about creating those identities in Azure AD or Entra ID, right? That's fine. You can still create your unique identities in Azure, but you can integrate with that, with AWS IAM Identity Center. What it does is that it allows you to federate using a SAML over a scheme protocol. And not only that, you can, yes, the user comes in, federated, and you can apply the same fine-grained access control to your user, and you can achieve this control standard, right? Let's jump onto the identify cybersecurity principle. Now here we are still, it talks mostly about governance, but yes, we see more technical controls are introduced in identify. So for example, in here, similarly like before, we try to map those guidelines with this principles, and we said, these services can be used to achieve different controls specified in this cybersecurity guideline, right? For example, starting with control 1807, which talks about having an asset discovery within your environment before you go for vulnerability scanning, right? And now how are you going to do that? Because AWS, if you're operating, it's the AWS environment and your workloads which are running within EC2 instances or Elastic Compute Cloud or virtual machines, right? Part of it you will achieve with AWS config. Now, AWS config is your configuration management system, right? What it does, it helps you in assessing, in auditing and evaluating the configuration of your AWS resources. Like, for example, who created S3 bucket? Who created that KMS key? And if it is still there, who changed certain things? So it gives you the whole lifetime, and it also gives you the whole relationship between different AWS services. But it's doing your configuration management of your AWS environment, not your machines, your applications, right? For applications running in your EC2 instances or your virtual machine, you're going to be using System Manager. Now, System Manager has a feature called inventory. What it does, it collects in your running instances, it goes and with the help of an agent, it collects OS versions, patch levels, software installations, licenses, files, Windows registries, and whatnot. And it can also, information can be integrated within config. It has its own dashboard. And not only that, you can also export that data into CloudWatch to your S3 bucket, where you can run further insights. All right, now we're going to be jumping in protect cybersecurity principle. Now from here onwards, we're going to be talking more technical controls, right? A lot of technical controls. And protect being the most, I would say, what I've seen is that most of the cybersecurity guidelines are mapped to this particular cybersecurity principle, right? And we're going to see that how we have selected 5 of those cybersecurity guidelines, in fact, 4 of them, and we're going to be seeing that what are the different controls within each cybersecurity guidelines, and we'll see how you can address your control requirements. Starting with software development. Of course, if you're talking about security, if you're talking about everything, we can't go without discussing Gen AI or AI, right? So it's still there. Luckily, ISM introduced 2 controls for Gen AI or LLMs last year, right? One is ISM 1923 and one is 1924. 1923 talks specifically about OWASP top 10 mitigation. Like if you are an organization, government organization, and if you want to implement or deploy a Gen AI or AI application, you have to make sure that your application has a well mitigation plan against OWASP top 10 vulnerabilities for LLM and Gen AI application. Now, 1924 control talks specifically about controlling on LLM output. Whatever LLM is generating as an output, how you're going to control that so that it will not leak out or generate any harmful or sensitive information. So as an organization, you have to take care of these things. And this is what that control says. All right. Now, since I'm assuming that most of us are from security background here or knows something about compliance as well, OWASP or Open Web Application Security Project is quite famous, right? And they have created, for years, they have created OWASP top 10 vulnerabilities for web application. With advancement of AI and Gen AI in recent couple of years, what they have done is that they came up with similar vulnerabilities, top 10 for Gen AI and AI applications, right? And that's what we're going to be talking about. Before that, let's see what is the typical Gen AI or AI application looks like. You know, there's a user that interacts with an application that has a business logic, and that application talks to LLM or large language model. That model basically can get information from different knowledge bases or RAG, or even have an agents that go and do some actions on behalf of an LLM, right? So this is your typical application. And if we plot those vulnerabilities against this application, typical application, you're going to see that these 10 of them poses different threats. And most of them are around LLM itself, right? And its application as well. Now, holding on this picture, we will see which AWS services and the potential design pattern, right, that can mitigate the vulnerabilities and help you in mitigating or achieving that control objectives from ISM, right? Now, from the first thing, Amazon Bedrock, if you are aware, can replace that LLM and the knowledge base part of it, right? What is Amazon Bedrock? It's a fully managed Gen AI application service built for developers and for organization that speeds up in development of Gen AI application securely, of course. What and why we use Bedrock? Of course, none of the customer data is used to train the underlying model. All data is encrypted at rest and in motion using KMS or key management service. Its fine-tuned models are encrypted and are stored within your VPC, so it's not stored somewhere else. It remains in your virtual private cloud. It is integrated with the identity access management for fine-grained access control, and above all, it is IRAP assessed. So you can say that yeah, it is IRAP assessed. We can use it to build application, right? Let's plot this diagram. We'll go a bit deeper, probably touching 300 level here, but it's important to make you understand how can we architect the solution to meet that control objective. This application over here, you see that we have an application VPC where we have a Gen AI application of front end probably, right? And with it's maybe serverless or three-tier architecture, doesn't matter. What it is doing is that it is talking to Amazon Bedrock, right? Now, it is using AWS private link, which is a dedicated link created just for Amazon Bedrock, so that only your application within your application-defined VPC can talk to Amazon Bedrock, right? Nothing else can get access to it. Only your application, not even your users, just an application itself, by giving it an appropriate access policies. VPC, a private link has VPC endpoints where you're going to apply those policies to have that fine-grained access control. Next is your LLM, which is residing in Amazon Bedrock, needs to access some data sources, maybe RAG, stored in S3. How are we going to access it? It will going to access it using S3 gateway policies, right? And whereby it will define, hey, you know what? Yes, this is a S3 bucket. First of all, it is encrypted with KMS, with my own key, and it can only be accessed by Amazon Bedrock service, right? Having that associate role, IAM role defined. Similarly, your Bedrock needs access to a vector database. Amazon OpenSearch, which is your vector database, which can act as a vector database for your Gen AI application, can be architected in a way that, first of all, it will going to be requiring a particular role from Amazon Bedrock to access that service. Secondly, you're going to encrypt that data using KMS with, again, your defined managed keys. Thirdly, it's going to have a data access policy that not the service itself, but the data within can only be accessed by Bedrock, right? But by that particular model, right? By that particular application. Last but not the least is your agents. Now, Bedrock has capability that help you in building AI agents, right? Now, those AI agents cannot talk to anybody else, I mean, any APIs or any functions without having a prior access. So you're going to be having that access given to the Bedrock service so that they can achieve access to it. And of course, nobody else can access those functions without your permission. And above all, you're going to be having Shield Advanced and WAF for the protection of your application, right? Because we have to mitigate the top 10 vulnerabilities, right? And if you plot here, you're going to see that 5 of those vulnerabilities identified by OWASP are covered by Bedrock and by Shield Advanced, WAF, your IAM policies, VPC private link, and KMS, right? Those combination helps you in achieving that. What about the remaining 5 of those vulnerabilities, which are basically related to input and output? Amazon Bedrock has a feature called Guardrail. Now, Guardrail provides configurable safeguards to help detect and block harmful content and prompt attacks. You can define topics to deny and disallow specific topics of interest. It can help redact PII information. You can additionally, importantly, you can use automated reasoning. Now, what you're going to use automated reasoning for to identify any potential hallucinations. It can identify, it can correct, and explain factual claims in model response as well, right? What about the output? The output, in a similar way, when the model creates an output, it goes through something called contextual grounding checks to make sure that the model is not giving out any sensitive information or any information that may kind of pose as an information leakage, right? So this is, if I plot those remaining 5 vulnerabilities, you're going to see that this is how we're going to, Bedrock Guardrails covers both the input and output side of those vulnerabilities, right? So that was about GenAI. Now coming back to some more traditional areas, let's say networking. So controls like 1181, 1579, and 1431 talks about network segregation, demand-based scaling, and DOS mitigation. And if I see this typical 3-tier architecture on AWS, you can achieve it by different services, right? You can achieve this DOS mitigation by Shield Advanced, auto-scaling group, and your subnet. Similarly, the controls around databases, right? That talks about, hey, your database and your web server should be in a separate logical groups. You should encrypt your communication, and the information at rest should be encrypted as well. How can I achieve that? Same diagram. I've added one more layer, and if you see here, with subnetting, you can separate your app server and your database servers. And not only that, with KMS, you can have your encryption at rest for your storage or attached to your database service or your virtual machines, as well as you can encrypt using TLS for anything in transit, right? So that was all from product side. I'm going to ask Champ for talking rest of the controls.
Thank you, Farhan. Isn't it interesting to see that if you use few of the AWS services, that can help you meet multiple ISM compliance controls? Now, a quick show of hand, if you think whatever you have seen so far is a lot. Few. Yes, exactly, and you are absolutely right. And the reason being, I hinted you before, there are 900 plus cybersecurity guidelines. And we have 164 AWS IRAP assessed services to support your journey. So under the detect principle, it's focused on timely collection and analysis of event logs, which can help you to recognize potential security findings at some stage. Now, I've mapped some of the AWS services with cybersecurity guidelines. I'm going to pick two interesting ones here, networking and systems monitoring, to do a reference architecture based on that. So let's start talking with control reference architecture for ISM 1030. It specifically talks about having a capability such as NIDS or NIPS in your environment to do deep packet inspection. Now in AWS, we have network firewall, which is a managed service and easy to deploy, provides you essential network protection. The network firewalls provides you two different levels of rules, stateful and stateless. Stateless rules is very simple. The name as suggests, filter the traffic as it comes through, and based on the action you have defined, pass, drop, or send it for further inspection. Now, if you are talking about stateful inspection or rule engine, it is more complex and kind of gives you liberty to write your own custom rules and set the inspection accordingly. Now, network firewalls comes with a detailed logging feature as well. Let's talk about some of the traffic inspection pattern. There could be 5 patterns between the subnets within a VPC, between the VPC within a region, between the VPC in different regions, or the last two ones, if you are operating in on-premises, you may want to talk to that, or talking to the internet directly. So I've placed that while you are communicating to the internet network firewall, which will help you to real-time network and application layer protection against vulnerability with the help of AWS managed signatures. Now, those are managed by AWS and keeps on updated at the background. But what if you have some unique requirement? You can use Suricata open source IPS specification as well and write your own specific rule according to your requirements. Let's move on to the next one, cybersecurity incident. Ahead of an investigation, you want to capture the log. And we are talking about detection functions, so we want to capture all the logs. So ISM control 0120 and 1803 talks about ensuring access to the data all the time, and also a structured incident logging, maintaining a cybersecurity register. Now, in Amazon Guard Duty is an intelligent threat detection service, and the best part of this service is it can analyze tens of billions of events across multiple sources, such as VPC flow logs, CloudTrail, DNS query logs. There are opt-in protection plan available as well if you want to do it. So it partly covers the ISM 0120. There was a requirement to have the data access all the time across your assets. So what you can do is you can deploy with the delegated administrator feature so that any new AWS account you onboard will automatically have the guard duty activated and will send the centralized log into the designated account which you have defined. Now, there is a feature of extended threat detection, which look at the attack sequence across your data sources in a time window to provide you a specific finding. Moving on to the CSP respond. So the respond principle talks about handling the incident effectively, which include incident management. So these are the CSP we map data. I'm going to quickly touch base on cryptography and systems management for cyber resilience specific to the data resilience. So the first ISM 1091 in cybersecurity principle, key material rotation. It ensures that if something happens, you are able to rotate the key. So AWS key management in AWS is a managed service, helps you create and control the cryptographic keys, which are stored in HSM. And what are the ways you can do that? There are 3 ways, actually. So you can use AWS managed store. AWS manages on your behalf, or you can choose to use a custom key store within AWS account or externally. So if you are using one of those, you will be able to rotate the keys as and when required. But how about if you are using AWS KMS key only store? You can choose to rotate the key automatically at a certain period of time. Since we are talking about incident, you can also do that on demand. If you are familiar with KMS, it uses envelope encryption. So there will be data keys as well, which actually encrypt the object. You can use re-encrypt function to rotate those keys too. So let's move on to the ISM control 1515. It talks about ensuring the data backup. An interesting part here is the restore testing. You should be able to demonstrate that. And the purpose is, what are your organizational RTO goals? You need to demonstrate you are able to meet it. Right? We do all the time backups, but how about the restore testing? Let's take a look quickly. So many enterprises operate in hybrid environment. AWS backup helps you to take backup of your AWS environment as well as on-premises resources. And it gives you a centralized console where you can have a consolidated view of all of your assets. Now let's quickly talk about the reference architecture. So let me explain here. ISM does not specifically say you should have certain number of copies of data backup. However, there are industry standards. It talks about 32110. So if you are using that or you want to have the maximum data resiliency, you can follow that. Let's quickly see what we are talking about. So we create a delegated admin account to define our backup policy and pattern, KMS keys so that we can encrypt the backups, a data bunker account to have an isolated backup copy in the same region. Now we want to ensure nobody can touch our backup and certain authorized user can only do the restore function. We'll define the SCP using AWS organization. Now this is our workload account, like from 1 to n. So let's start taking the backup here. We'll store the first backup copy within that AWS account. Now we also say that AWS account itself represents a security boundary. We'll store the second backup copy in the same region, but in another account, so that you can define the service control policies. Now, if you want to have a data resilience maximize, you can have another region to create your data backup vault as well. And not to mention, all these backups are encrypted with your own KMS key, which you control. You define the key policies as well. And finally, you do need to have a forensic account to do the restore testing, or in any scenario you need to do a forensic, you will choose to do that. Now this talks about the overall backup reference architecture following 32110 methodology. How about the restore testing procedure? AWS backup has that functionality which you can leverage across your storage, compute, or database environment. Define the policies. You will be able to test it, create a plan, and then with the evidence, you'll be able to demonstrate the successful completion or otherwise. Now here are some AWS guidance and resources, QR code. Feel free to take the picture. Anyway, this talk will be uploaded in YouTube. You'll be able to do that in your own time, because I know it's a lot we've covered in this talk, 30 minutes. Finally, security isn't just a feature at AWS. It's foundation to everything we build. When organizations like the Australian government chooses AWS to build their top secret cloud, it's because they recognize our commitment to security. So a quick summary here. We looked at the ISM principle and guidelines. We did the mapping with CSP, CSG, and AWS services, which is crucial part. But there are 900 controls we talked about, which this services or the architecture reference will give you a starter to understand how you can map the remaining controls. And then you can build a compliant architecture. I hope you found this session useful. If you have any question, we'll be back in the venue. You can reach out to us. Any questions we want to help you with, we can do that. Also, you can connect with your AWS account team if you want to have a separate offline conversation with us as well. Thank you so much for listening, and please do not forget to fill out the survey. Thank you so much.
Awesome.